Hi, hello everyone. मेरा प्यारा बच्चा लोग, my beautiful, awesome, great, super great students. Tell me कैसे हैं? How are you all doing? And a very warm good afternoon, every one of you. Or should I be going with good evening, whichever is suited at this point of time, which is 4 o'clock. Hi Gia. Who all we have here? Everyone, just give me a hi and let me know. Okay, कैसे चल रहा है सब? Okay, how's everything happening? Hi Mansi, good evening, good evening, good evening. Hi Meera. हाँ बिल्कुल बढ़िया. I'm doing so good. What about you all? सब बढ़िया चल रहा है? Hello boy, I'm fine sir. औरों को पता नहीं. मतलब what do you mean by that? Okay. Fine. So I'm so glad that everyone is here. I'm so happy to see that because of some issues I had to change my time. You know? We usually used to have our classes at 10 p.m. right? So I have shifted it because of some issues here. But I hope you all are here. I'm so happy for that. And if you're seeing me for the very first time, this is Ameer, your physics educator at Unacademy, and here we are in this beautiful session to learn about thermodynamics in 1 hour, right? Which means we'll be going through the important concepts of this particular chapter of thermodynamics in 1 hour. Whatever is required for getting full marks from the topic of thermodynamics will be covered in 1 hour, and I hope you all are ready, okay, to spend that 1 hour with me and to learn this particular topic, right? Yeah, it's okay, Miara, any time for you. Arey, thank you so much. अरे मेरे पास कुछ भी नहीं है शिका. Okay, so खरीदना चाहिए मुझे स्मार्ट बोर्ड. अरे मेरा स्मार्ट बोर्ड it is in home actually, as you all know. Right now I'm in Bangalore, so and here we are. ठीक है. Now if you're meeting me for the very first time, a bit of introduction about myself. I hope you all can see it on the screen. Right, I have an experience of more than 3.5 years in the field of teaching JEE, NEET and board student. I am a BTech graduate from NIT Calicut in Mechanical Engineering, and this is all about me, more about me obviously. You'll come to know as we proceed with the classes, right? Or kya? Now if you don't want to miss any of the live classes and live updates of this YouTube channel, everything will be uploaded and updated in our Telegram channel. The link for joining the channel is given here and in the description box. Bugs Bounty, I hope you all know, right? It will help you to get lot much of prizes if you can report any inappropriate content in the videos uploaded by Unacademy. Now, compact scholarship test. You all know this is one simple, amazing way for every one of you to grab as many prizes as possible, right? So one thing is registration for the scholarship test is completely free. You simply have to use a code of AMB10 here, okay, for registering to it. Now, if you register to and if you start writing, if you get a first rank, gold medal is waiting for you. For the second rank, silver, and for the rank 3, gold medal is going to wait for you. So don't miss your chance. And for the first 3 ranks, not just that, 1 year of Unacademy free subscription is also given to you. Others, don't worry, scholarships are waiting for you. Now, Unacademy Plus subscription, you all know awesome features are there, so don't miss it. Okay, unlimited access, top educators of the country, study material, practice test, live test series. If you go for 12 months, it should cost you 1,250, and if you want 10% of discount, don't forget hamara code hai na? It's AMB10. And we have iconic subscription too, where we have extra features such as personal mentor, light outs online classes, weekly reports. So if you go for 12 months, it should cost you 2,333 per month, and if you can use a code of AMB10, you can avail 10% of discount and enjoy being a part of Unacademy family. So tell me, I think it's time for us to get started with our session. So I just want from you all to know that are you all ready for that? Ready? Just open your notebook and pen and start writing. This is the time. आपका हिंदी बहुत awesome है. Okay, I'm just learning the language, right? I know that you made fun of me. Okay, let's start everyone. Ready? Okay, so I hope you all are there with an open book and a pen and all ready to start, right? Hi, and Shreya, Jia, Sana. Yeah. Sana is also there. Shreya, yes, are ready? Super duper excited. Okay. Now, let's start with the chapter of thermodynamics, as you all can see it here, right? Okay. Now, in the topic before thermodynamics, we were learning about thermal properties. In that chapter, we have learned about heat, ठीक है, it's different from temperature. And what happens between those two bodies if there is a temperature? Heat transfer happens, right? We have seen how to calculate the amount of heat transferred, right? All these things is being done in the previous chapter itself. So in this chapter, thermodynamics, what we are going to do? We are going to see, right, when a heat energy is being given to the body, to what it is getting converted to, or to which other forms of energy this heat energy is getting converted to, right? Or is this heat energy doing some work, right? And what all things it is being done to the gases? So many answers, okay, will be answered in this particular class or in this particular chapter of thermodynamics. That's what we're going to do. Okay, fine. Now let's get started. The first thing is we want to know what is equilibrium, right? When can we say that two bodies are in thermal equilibrium? Let's see that. Thermal equilibrium, first topic of discussion. क्या है? Thermal equilibrium. होता क्या है ये? देख ले, we have two systems. Okay, let's say we have two systems, a system A and we have a system B. ठीक है. Let's say the system A is having a pressure of PA, volume of VA and temperature of TA, right? Okay, and the B is having obviously the pressure of PB, VB and TB. Okay, so two different systems are there, okay, where there is a line of separation between the two systems, as you all can see. Okay, fine. Now, if this wall that separates both the system, let's say it is a diathermic wall. Diathermic wall. I hope you all know your diathermic wall क्या होता है. And what is diathermic wall? That wall or that separation which allow the heat energy to pass through, which allow heat energy to pass through. वो होता है diathermic wall, right? So if there is a diathermic wall which separates both the system of A and B, okay, what will happen? As there is a temperature difference, and considering TA is greater than TB for the time being, as there is a temperature difference, tell me what happens. Yes, from the system of higher temperature, which is body A, right, the heat energy will be transferred to the temperature of body B. So delta Q will be transferred from the body A to the body B. And this keeps on happening till when? Till both of them achieves a common temperature, right? Till both of them achieves a common temperature, the heat energy will keep on getting transferred. Now, once they achieve a common temperature of T, let's say, will there be any further movement of heat energy between the systems? No. Now, when there is no heat energy flow between the system, then we say that both the bodies are in thermal equilibrium. Or in simple words, when can we say that two bodies are in thermal equilibrium? If both has same temperature. ठीक है? Once both the system is having the same temperature, we can say both of them are in same thermal equilibrium. Array, same temperature hai to, will there be any further flow of heat energy? Obviously not. So we can also say that two bodies are in thermal equilibrium if there is no heat energy flow between the system. Okay, these are the two different ways of explaining or defining what thermal equilibrium is. समझ में आ गया? मिथिलेश, श्रेया, जिया. Okay. Fine. ठीक है. Now, let's have a look at it. Everybody listen. Just now we have discussed about diathermic wall, right? And what is a diathermic wall? That allows heat energy. So many of you might have thought, sir, what do we call those walls which does not allow the heat energy to pass through? Is there such a wall there is? Yes. So that wall which will not allow the heat energy to pass through, we call it as adiabatic. Adiabatic. Okay, so adiabatic walls or adiabatic separations are those which will not allow heat energy to pass through it. Okay, so we have learned actually three things right now. What is thermal equilibrium? Okay, what is a diathermic wall? Done. What is adiabatic wall? Cool, is it fine? So we have discussed these three things right now. No doubts, I suppose. Again, na samajh? Only just three things that we have learned till now. Any doubts? Anyone? कोई भी डाउट है तो बच्चा लोग, this is your time. Clear? Yes? Okay, fine. Good. पक्का आ गया और क्या? Now, we will start with the laws of thermodynamics, right? So the first law is the zeroth law of thermodynamics. Zeroth law of thermodynamics. How it became zero, I already have told you that funny story, right? And I don't know how many of you found that story as funny. वो मुझे भी पता नहीं, ठीक है? Fine, okay. Repeat कर दो thermal equilibrium. अरे, two systems, if both of them are having same temperature, we call it as thermal equilibrium between the systems. That's all. What is there more to explain about that? इतना सीधी सादी concept है ना? ठीक है. देख ले. What is zeroth law? I can draw just a figure which is also given in your NCERT, right? And I can explain you right away what is zeroth law. Not a big deal at all. देख ले. Here, I'm going to introduce three different systems: System A, System B, and System C. Now, the wall which separate between the System A and C, and that B and C, these two systems, I'll mark it with a different color as you can see. These two systems, these two walls. Let's say these two walls are diathermic walls. Okay. And what about this one? That wall which separate between A and B, that is called as adiabatic wall. That is adiabatic. Which means if this is the configuration we have, it's obvious that heat energy will not be transferring between the systems A and B, because between them it's adiabatic wall. Okay. And what about A and C? Obviously, if they are having different temperatures initially, there will be a temperature flow, right? And the temperature flow will keep on happening until the system A and C is in equilibrium, right? Okay, same process happens. B and C is in contact through a diathermic wall. Heat energy will be keeping on transferring, right? Until the system B and the system C is in thermal equilibrium, right? So we can say that system A and C will be in thermal equilibrium. So if C is having a temperature of Tc, and if system A and C are in thermal equilibrium, system A will also be having the same temperature. Then only we can say that both of them will be thermal equilibrium. ठीक है? देख ले. If the system C is having a temperature of Tc, and as the system B and C is connected to a diathermic wall, what happens? Obviously, heat transfer happens between the system B and C, and between B and C also a thermal equilibrium will happen. And when thermal equilibrium happens, right, both the system will be having same temperature. So C, whatever is its temperature, the same temperature will be that of B. Understood? So here you can see that the system A and the system B is in thermal equilibrium with the third system C separately. System A and C in thermal equilibrium, system B and C in thermal equilibrium. No equilibrium contact or no heat energy transfer between A and B. But still, dekh le, system A and system B will be in thermal equilibrium. Yes or no? System A and system B will be in thermal equilibrium, and this is what is said in zeroth law of thermodynamics. It says if A and C are in thermal equilibrium, B and C are in thermal equilibrium, A and B will be in thermal equilibrium. Simple. The most simplest law from thermodynamics. Nothing more to learn from here, right? It is almost like if A equal to B and B equal to C, obviously A will be equal to C. Same concept. A and C are in equilibrium, B and C are in equilibrium, obviously A and B will be in equilibrium. That's it. Again, so much. Zeroth law of thermodynamics. Cool. Yes, awesome. All good. Sana is like, story. What was the story? There was no story, nothing like that. And though usually most of the time in all my classes I usually start the story for Zeroth Law of Thermodynamics as there is a funny story, and after I tell the story at the end, students will be like, sir, we couldn't find anything funny here in the story, and I'll be like, this is what happens. Hi Preeti, clear Mithilesh? Yes, Shreya, Miara. Okay, look, Miara is also already telling that sir already pranked us. Okay, so we'll proceed, right? So thermal equilibriums are done. We'll proceed further. Okay. Everybody, listen here. Moving on. Now, we have completed Zeroth Law of Thermodynamics. So now we have to learn about the first law of thermodynamics. Fine. But before getting into first law of thermodynamics, we must understand, or we must have a very good clarity about all the terms that we use in first law of thermodynamics. Okay. So which are those terms that we use in first law of thermodynamics? Okay, starting with internal energy. I know that still, though the complete chapter is over, many of you are still having the doubt of what internal energy is. Always represented with the symbol of U. What is this internal energy? Let's say I am taking a container with so much of gas molecules in it. Okay, so much of gas molecules are there. Fine. Obviously, the gas molecules are moving, which means it has speed. When it has speed, it will be associated with the kinetic energy. Yes, all the molecules will be associated with the kinetic energy. Yes. Now, the molecules are having some separation or distance between them. Yes or no? The molecules will be having a distance between them. When there is a distance between the surface of the earth and another body of mass m, which energy is associated with it? mgh, or potential energy. So similarly, as there are so many molecules inside this container, which is gas molecules, and as there is some separation between them, there will be existing potential energy. Matlab, the molecules consist of kinetic energy and potential energy, and the sum total of kinetic plus potential energy is what we call it as internal energy. Okay, Carnot engine is not there for our syllabus. Who asked me math, physics, chemistry? It's not there. Fine. Ishiga, sir, where is your smart board? You look smart with smart board. Okay. So seems like every time, okay, to make myself look a smart person, I should be carrying smart board. That's what you say. That's very bad. That's really mean. Okay, coming back. Let's continue with this. Okay, so we just got that internal energy is the sum of kinetic energy plus potential energy. The sum total of kinetic and potential of any molecules present, right? We call it as internal energy. Okay, fine. Now let me say that internal energy is directly proportional to temperature. Okay, the internal energy is directly proportional to temperature. How is this possible? I can explain. I am increasing the temperature of this particular gas molecules, right? When temperature is increased, tell me what happens. The particle will start moving faster. Matlab, the speed will increase. Temperature increase ho gaya, speed increase ho gaya, right? When speed increases, kinetic energy increases. When kinetic energy increases, U is only increasing. Matlab, internal energy increases, right? Which means we can say that if there is an increase in temperature, there is an increase of internal energy. And if there is no change of temperature, right, there is no change in internal energy. Is this concept clear? Right? Matlab, the internal energy is directly proportional to temperature actually, which means that if there is an increase of temperature only, we can experience an increase in internal energy. If it is not happening, there is no increase in internal energy. Samajh mein aa gaya? Is it clear? Matlab, if temperature is remaining as a constant, the internal energy will also be remaining as a constant. This is what, okay, this is what it says. Clear? All good? This is all about internal energy. Now, when the chapter was discussed, I also have introduced this particular word, that internal energy is a state variable. Do you remember that? बच्चा लोग याद है? What was a state variable? What do you mean by state variable? State variable का मतलब ये है कि those physical quantities, right, which depends upon the initial state and the final state of the system, not on the path, right? Obviously, we know that for any system to move from an internal energy of U1 to an internal energy of U2, there will be different paths possible, right? So the value of internal energy does not depend upon the path we choose for reaching the final position, right? It only depends upon the initial state and the final state. Okay, so just like internal energy, we have so many physical quantities which are state variables. So I hope you understood what is meant by a state variable. Those quantities which depends only on the initial and the final position, and irrespective of the path we choose, we call it as state variables. And internal energy is one kind of a state variable. I can write what is a state variable here, you all can copy it down. State variable matlab, right, quantities which does not depend upon the path chosen. Which does not depend upon the path. वो होता है state variable. Yes. Okay. Clear, done, super clear. Everything about internal energy noted. Awesome, all good, all cool. Okay, okay, clear, noted, fine. So we'll proceed further. Now it's time to finally understand, right, the first law of thermodynamics. ठीक है ना? मुन्नोट दींगटे. Okay. So for understanding the first law of thermodynamics, मेरा बच्चा लोग सब ready है ना? सब ready? Thermodynamics. Okay, the first law of thermodynamics. Everybody, what does it talks about? I'll explain in detail, so don't miss any of these concepts. Okay, listen to me very carefully. Now here we have a container which is filled with some gas molecule. Can you see that? Can you see that? Yes. Now on top of this particular container we are keeping a movable piston, and let's say this is just an handle to that particular piston. Okay, this is a piston, okay, which means it can move up and down. Fine. Now I am providing some heat energy of delta Q to the system. Okay, I am providing some heat energy to those gas molecules. Delta Q matlab heat energy. I am providing heat energy. Tell me what happens to the heat energy that you provide. The heat energy that you provide will increase the temperature of this. Temperature increase ho jayega, hai na? When temperature is increased, you can see that the particle moves faster, or speed increases, V increases. When speed increases, what happens along with that? Kinetic energy increases, right? Not just speed. If you are providing heat energy, right, the molecules will be moving far apart. Matlab, the distance between the molecules or the atoms will increase with the increase of heat energy that you provide. Tell me, once the molecules move far apart, which energy will be increasing? When the distance between the molecules increases, kinetic energy increase ho jayega. So along with increase of kinetic energy, potential energy will also be increasing, right? When the molecules move apart, potential energy increases. Okay, so increase of kinetic and potential increase will result in the increase of what? If these two increases, the sum of kinetic and potential is called as internal energy. so internal energy increase हो जाएगा. हाँ क्या? Is this clear? So the increase of kinetic and potential energy will result in the increase of internal energy here. Fine. ठीक है, molecules will dance. ठीक है. Okay. Now listen to me. Is this the only change that can happen here? No. When the molecules start moving faster, as you all can see, it can make a huge amount of collisions, right? Larger collisions here. Bada collisions it can make. So when it makes huge collisions here, it means a force will be experienced by that container, right? The force will be experienced, and because of the force, the piston can move upward. Because of the force, the piston can move upward like this. Let's say the piston will be moving upward by a distance of x. मतलब gas molecules provide a force and displace a piston. Force and displacement makes what? Force and displacement makes what? Force and displacement. Force and displacement. जल्दी बता. Force and displacement makes what? Force and displacement makes work done. Yes or no? Okay. मतलब whatever is the heat energy that you provide, delta Q, right? It is used for increase of internal energy plus, and some of the heat energy is used for providing the work. And this itself is the exact formula for the first law of thermodynamics. That is delta Q is equal to delta U plus work done. मतलब heat energy you provide is used for two purposes. First thing, for increase of internal energy. Second thing, for work done. Clear? Nanu munu concepts are. Right? Not a big deal at all if you all can do it. Yes? Beautiful, right? Okay. Now, when using this formula, ठीक है, मेरा math physics मिथिलेश clear? ठीक है, बढ़िया बढ़िया बढ़िया, देख ले, आगे देख ले, चलो, ठीक है. Now, while using this formula, right, it is very much important to provide the sign convention Q, because you know that heat energy can be provided to the system also, and we know the heat energy can be grabbed from the system also, right? We can take heat energy from the system, we can provide heat energy to the system. So in order to represent whether the heat energy is given to the system or taken from the system, here we have the sign convention, right? According to thermodynamics of physics, right, if heat is given to system, what is the sign? If heat is given to the system, हम दे रहे हैं system को, okay? If we give heat energy to the system, when it receives heat energy, हाँ, happy हो जाएगा, right? Happy का sign क्या है? Positive. Be positive. So when we give heat energy, while receiving the heat energy, and a system becomes so खुश, so happy हो जाएगा. So it will be having that positive sign. ठीक है. Now when heat is lost, heat lost by the system. When the system loses heat energy, when it loses, it will become so sad. Okay, sad का sign क्या है? Negative. Okay, negative हो गया. So this is a sign convention for heat energy given. Now there is a sign convention for work done also, very important. Now in the above case, shall we do this also? Last part, मतलब last part from first law of thermodynamics. ठीक है, देख ले. Now in the above case, as you can see, sorry. Okay, so in the above case, right, the piston is moving upward, है ना? Piston is moving upward, and why the piston is moving upward? Because the force is provided by the molecules of the gases, right? And the force is provided by the molecules of the gases in the upward direction, and piston moves upward. In this case, we say that work is done by the gases or by the system. Okay, when will we say that the work is done by the system? If the piston moves upwards, right? Okay, we can write work is done by the system. Piston move upwards. Okay, piston moves upward, and when the work is done by the system, the usual sign for that is positive. Okay, when the work is done by the system, when the piston moves upward, right, work done का sign होता है positive. Clear? Okay. One more thing, don't forget to note it down. Right. Now, when the piston moves upward, what is happening to the volume? Array, what is happening to the volume? Just look into the figure. Piston moves upward. Initially, this much was the volume. Right. Now, when the piston moves upward, volume तो ज़्यादा हो गया, बड़ा हो गया, है ना? बड़ा हो गया हमारा volume. So, volume is basically increasing. So, we can say that work is done by the system. वॉल्यूम तो इंक्रीज हो जाएगा, ठीक है, एंड वॉल्यूम इंक्रीजेस, वी कैन से दैट वर्क डन इज पॉजिटिव. क्लियर? वॉल्यूम, आई कैन राइट इट हियर, वॉल्यूम increases. So these are the three different time we call the work done as positive, which all cases either work done by the system. ठीक है, काम कर रहा है कौन? सिस्टम काम कर रहा है to make this piston moves upward. Okay, work done positive होता है. In another words, you can say the same thing as, अरे when the piston moves upward क्या हो रहा है? Volume increase हो रहा है, right? So when the volume is increasing, also we can say that work done is positive. So in either of the case, you can say that work done is positive. Clear? Clear है ना? Not a big deal. I hope you all can understand this. Just like that. नन्नू मुन्नू concept है, प्यारा सा concept है. Delta Q as Q2 minus Q1. Yeah, the extra amount of heat energy. Cool. Yes, clear. Aha, Preeti. Thank you. Thank you so much. So, whatever question pop-ups from first law of thermodynamics, you just need to use this particular equation use करना है, ठीक है, and ये sign convention use करना है. There is nothing in this universe that can help you or that can get you wrong answer. ठीक है? Okay. Preeti, just look there. Sana is telling that I gave you something to say all those words. Everyone is blaming me. मैं कुछ भी नहीं किया. Okay, zeroth law is all over. Internal energy we already have discussed. Heat energy is being discussed. Work done, first law of thermodynamics discussed. Right? What is left? Okay. Now molar heat capacity. देख ले. Everybody listen here. Everybody. Right? Now, what was molar heat capacity? That is not a topic from thermodynamics. It's from thermal properties of matter. We already have discussed, right? But anyway, I'll just give you a small heads up. Those who forgot what is molar heat capacity. क्या है? Molar heat capacity. Okay, it's very simple to understand. ये molar heat capacity क्या होता है? देख ले. I have a body and it contains 1 mole of material, मतलब 1 mole of atoms or molecule, 1 mole we have. Now, if I want to increase the temperature by 1 degree Celsius, don't we want to provide some heat energy for this? Yes, and this heat energy provided, we call it as molar heat capacity. What is the definition? Heat energy given for increasing the temperature of 1 mole of a material by 1 degree Celsius. Which means the heat energy per unit mole per unit change in temperature, ठीक है, that is actually the molar heat capacity. Okay, वो होता है molar heat capacity. This is something we already know. ठीक है, this is something which we already know, but there is a small difference here, right? In the case of gases, if we are trying to find out this molar heat capacity, which is the heat energy required for unit temperature increase for unit mole, right? It was found out that if we are finding molar heat capacity at constant pressure, matlab if you keep the pressure as a constant for the system throughout, okay, and if you are trying to find out the molar heat capacity, a particular value is being found out, which we mark it as Cp. Okay, and in the next case, during another thermodynamic process, if you are keeping the volume as a constant when the process was being done, right, related to the gas. If you are keeping the volume of that gas as a constant, it was found out that the molar heat capacity is having a different value for the same material. Okay, even if I take same material and if I find out molar heat capacity, right, at constant pressure one value to be obtained, and at constant volume it obtains another value. So molar heat capacity measured at constant pressure, we mark it as Cp, and molar heat capacity which is being found at constant volume, we mark it as Cv. Okay, so Cp is a molar heat capacity at constant pressure and Cv is molar heat capacity at constant volume. Okay, yes? Clear? Clear है ना? चलो. Yes, yes, yup. ठीक है, नोट किया सबने? What is molar heat capacity, what is Cp and what is Cv, right? You just need to go with the formula, basic formula, and what is Cp होता है and Cv क्या होता है. ठीक है, अच्छे से clear. Okay, now moving on. Now what we're going to do is, by using the first law of thermodynamics for different gases, we're going to find out the relationship between Cp and Cv, right? Okay, so by using first law of thermodynamics, we are going to do that. First, we are going to find out Cv का value क्या होता है. For that, let us take a system. Initial pressure is Pa, Va and Ta. Now this system, by providing the heat energy and the work being done on it, I am changing the value of pressure to Pb and the temperature to Tb by keeping the volume as a constant. Now if you look into this process, right, you can see that the pressure and temperature is being changed but the volume is being kept a constant here. So if we measure molar heat capacity, which C we have to use Cv value. ठीक है, no doubt in that. Okay, now okay, but before the derivation I forgot to give you one single thing, right? Work done का formula. Work done का formula होता है P delta V. This is very important, right? I forgot to mention this. I think obviously we have done the derivation in our proper classes. ठीक है, for the time being you can note down work done का formula is pressure into change in volume. Okay, now we can continue with our equation. Okay, देख ले, we know that delta Q is equal to delta U plus work done, and work done का formula is equal to P delta V. In this case of thermodynamic process, what will be the value of change in volume? Delta V कितना हो जाएगा? VA and VA change will be equal to 0. So work done will be equal to 0 for this particular case, which says delta Q is equal to delta U plus 0, which is delta U. ठीक है? Now tell me what is the formula for delta Q? Array, very simple. C equal to delta Q by N delta T. So delta Q is equal to NC delta T. Delta Q is equal to NC delta T. And as volume is being kept constant here, the C that we use here is Cv. So simply we got a formula for delta U as NCV delta T, very important. Clear? Very good. Sana, Mithilesh, Shreya, Preeti. Yes, 0 it is. We found Cv value yesterday only, now everyone should answer. How many of you remember? Got it? Got it? Very good. Awesome. Now, Cp value also, let's do it. Okay, Cp value also, if you got Cv value, understanding this Cp is not a big deal at all. कर सकता है ना? अरे देख ले, नन्नू मुन्नू कॉन्सेप्ट है. कैसे है? नन्नू मुन्नू कॉन्सेप्ट. We have a system, let's say pressure is Pa, volume is Va, temperature is Ta. You convert this to a new system where the pressure is Pv, okay, volume is Vb and the temperature is Tb. Let me say pressure is Pa itself, मतलब We are not making a change in the pressure. Instead, volume and temperature is being changed in this process. Okay. Now, can I apply the same formula? Yes. Delta Q is equal to delta U plus P delta V. Right? Okay. Now tell me, what is delta Q? Delta Q का formula क्या है? Just now we know that is delta Q is NC delta T. Delta Q is NC delta T. But here, which C value we have to use? Arey, pressure is kept as a constant, है ना? So Cp we have to use. ठीक है? Okay, is equal to delta U का formula just now we have derived. What is NCV delta T? Okay, that is NCV delta T. What is it? Delta U. Okay, plus P delta V. T. What will be P delta V? For that, you have to simply take your memories back to our ideal gas equation. PV is equal to nRT. है ना? देख ले. Here pressure is remaining as a constant. ये P तो constant है. So the only way you can change the volume is by changing the temperature, because N and R are already constant. ठीक है? So if you want to change the volume here, the only method is to change the temperature. So pressure into change in volume is equal to NR into change in temperature. Yes. Okay. So P delta V, what can I substitute it with? NR delta T. Okay. So NCP delta T, NCV delta T goes to the left hand side. N and delta T are common here. What do we have? Cp minus Cv. And here we have NR delta T. Okay. N delta T's cancels. What do we have? Cp minus Cv equal to R, and that's our final answer. Got it? Got any other class, Mithilesh? We haven't completed though. Okay, so we just have proved what is the formula for Cp minus Cv, right? No numericals. We'll be just discussing all the important concepts, derivation and formulas. Oh, okay, Mithilesh, best of luck. I know that you are gonna do simply awesome there, so go and do it. Fine. Done. Miara, great. Got it? Okay. Okay, funny sana. Okay, fine. Moving on. Now, let us discuss about different thermodynamic process, right? Ready? To discuss about different thermodynamic process. So, neither to explain what is thermodynamic process, I hope you all know. Thermodynamic process क्या होता है? देख ले. In the previous example, I was discussing, right? This is a thermodynamic process. So, what is a thermodynamic process? A process of changing the value of pressure, volume or temperature or any of these things. Okay, that process we call it as thermodynamic process. Okay? That process we call it as thermodynamic process. And all the thermodynamic process that we are going to learn here is a quasi-static process. Okay? What is this quasi-static process? Okay, quasi-static process क्या होता है? Quasi means almost static. Static means stationary. Almost static वाला process. मतलब those thermodynamic process which looks like almost stationary. Okay, how does it happen? कैसे हो सकता है? देख ले. We have a system of some liquid here. Initially, it is at a temperature of 300 Kelvin. Right, and you want to shoot this temperature to 600 Kelvin, right? So if it is a quasi-static process, and even if you want to change the temperature from 300 to 600, how will you change? And you will change it very slowly. From 300 you will change to 301 Kelvin. From 301 you will change it to 302, then 302.33. I say matlab you will change the temperatures very slowly until it reaches the final temperature or the final state. So quasi-static process means those thermodynamic process, okay, where the change is being made very slowly. Nannu munnu change if we are doing. ठीक है, we call it as quasi-static process. We can write it thermodynamic process, right, which change its value really slowly. Okay, we call it as quasi-static process. Okay, fine. That is called as a quasi-static process. So let us discuss some of the quasi-static thermodynamic process. You all know this is a very simple topic for every one of you. The first one is this, I hope everybody knows, isothermal process. What is an isothermal process? Very simple. If we are keeping the temperature as a constant throughout the process, we call it as an isothermal process, right? If the temperature is constant, change in temperature will be 0. And how can we express an isothermal process? By writing PV is equal to a constant. The product of pressure and volume will be remaining as a constant in an isothermal process. And if you want to draw a graph between pressure and volume for an isothermal process, graph will be like this, SA. Okay, the graph is going to be looking like this. Then what else we have? Pressure, volume, and yes. If temperature is a constant, tell me what will be change in internal energy. We already know internal energy is proportional to temperature. So if temperature constant, internal energy constant, right? So change in internal energy 0 ho jayega because change in temperature to 0 hai. Okay. Clear? If that's the case, what will be the equation of first law of thermodynamics for an isothermal process? That is, as delta U is equal to 0 here, we can say delta Q is equal to work done. In which case, in this isothermal process, very important. Okay, graph we have discussed. And one more thing, right? Finding out the work done. We are not going for the derivation anyway. Fine. Tell me, if we have a pressure volume graph, how can I find out the work done? Those who don't know, write it down. But chalo, this is very important because many questions pop up from this particular concept. Okay? Work done from pressure volume graph. Area under the graph. Area under the pressure volume graph corresponds to work done. This is our graph, right? What you can see, that hyperbolic graph over there. Now if I draw the area, or if I mark the area beneath that, it looks like this. Can you see that? So this area under the graph is what we call it as the work done. Okay, we have to do the integration, and obviously after integration we'll get the final formula for work done in an isothermal process is nRT ln V2 by V1 or nRT ln P1 by P2. Either of the equation you can use it here, but finally you'll get the same answer for work done. And that's all about isothermal. Isothermal process. Are all isothermal process adiabatic array? How is that possible, Mia? Right? It's totally different concept. Both are two different thermodynamic processes. Got it? Fine. Okay. I'm really sorry, but we won't be doing any derivations. Okay? Now we have adiabatic. Adiabatic का मतलब क्या है? Right? We are not giving heat energy to the system. Heat energy कुछ भी नहीं दे रहा है. We are not giving any heat energy. मतलब if heat energy is not given, right, the heat energy will always be a constant. And delta Q, the change in heat energy क्या हो जाएगा? Zero हो जाएगा for an adiabatic process. Okay, fine. Now I'll just clear out the doubt of Miara here. She asked me regarding the temperature cases, right? So I think the simple doubt that might have arisen here is, right, if we are not giving heat energy in an adiabatic process, how can there be an increase of temperature, right? In adiabatic we are not giving heat energy. So everyone can have this doubt. Sir, if we are not giving heat energy, how the temperature is increasing? We'll first write down the first law of thermodynamics. From there you'll understand. Delta Q is equal to delta U plus work done, right? Okay. And here I can write delta U is equal to delta Q 0 हो जाएगा because it's an adiabatic. So delta U is equal to minus work done. देख ले, even if you can do work on the system, work will increase the internal energy, and increase of internal energy will obviously be resulting in the increase of temperature. ठीक है? So here the conversion is between just internal energy and the work done. So if you want to increase the internal energy here, you can obviously do the work on it. आ गया समझ? Very good. Yes, Anna. Yes, due to work. Okay. So I hope your doubts might have cleared right now. Got it? Okay. So moving on. The equation to express an adiabatic process is PV raised to gamma is a constant. In an isothermal it was PV equal to constant. Here in adiabatic it is PV raised to gamma is equal to a constant. Okay, fine. Now you can ask me ये gamma क्या है? That is called as adiabatic constant, and ये gamma is the ratio of Cp divided by Cv. This ratio of Cp by Cv is actually called as adiabatic constant. Fine. Okay. Now, how to draw the graph for an adiabatic process? What will be the shape of a PV graph be? You will find it almost alike to an isothermal process का graph, मतलब hyperbolic graph you will have. But here in this case, though the shape is almost looking the same, right? For adiabatic, the slope will be more. Slope will be more. So you can ask me, sir, if there is a graph, a PV graph is being plotted in the same graph, okay, for adiabatic and isothermals, starting from the same point. So how can we understand which one corresponds to which one? मतलब which graph corresponds to adiabatic and which graph corresponds to isothermal? हो सकता है. देख ले, this is red one is one graph and the yellow one is the other graph. Tell me which one corresponds to isothermal. Tell me which graph corresponds to which thermodynamic process. You all can say, array, looking into those two graphs, right, the graph which has more slope, मतलब बहुत नीचे आने वाला वाला, okay, the one which comes down, okay, at a larger rate, which one is it? The yellow wala graph. So that has a more slope, right? Obviously the one which has more slope will be adiabatic. Fine. And the one has lesser slope will be isothermal. So if a question pop-ups like this, this is how you can identify. Yes, isothermal red. Mohit, Sana, yes. Good. Cool, simple, right? And here also we need to find the formula for work done, right? So work done here in an adiabatic process given by the formula of nr T1 minus T2 the whole divided by gamma minus 1. Yes, yellow adiabatic, yes. Got it? Okay, not a big concept. So after adiabatic process, हमको क्या है? What else we have? We have isobaric. Very simple. Pressure, if it remains as a constant, it is an isobaric process, right? And the equation to represent an isobaric process is V by T is a constant, volume by temperature तो constant हो जाएगा, right? And what else we have? Sorry for that. Fine. So that will be. And tell me, how can we draw a PV graph for an isobaric process? ये तो P है, ये तो V है. Isobaric matlab the graph should be corresponding to the same pressure. So the graph will be a straight line parallel to x-axis. Obviously, देख ले. All point, ये point, ये point, ये point, ये point, all point corresponds to same pressure. So it has to be isobaric. All cool, good, good, awesome. Nannu munnu concepts है ये सब. Okay, yes. Now here the formula for work done, the basic formula for work done, which is P delta V. Work done ka formula is equal to P delta V, here in this case for isobaric process. So graph is done, and this is the equation for work done. And there is no major change in first law of thermodynamics. First law of thermodynamics for isobaric, delta Q is equal to delta U plus P delta V. Same, because none of them will become zero, just like we have seen in the previous cases. Kunal Kumar, from where you got all those Chinese letters? कहाँ से ढूंढ कर आ रहे हैं आप? Okay, now two more processes are there. We are almost at the end of the chapter. Isochoric process. होता क्या? What is isochoric process? Yes, volume remaining as a constant. जब volume remains as a constant, we can call it as an isochoric process. ठीक है? अरे volume constant है तो delta V 0 होता है. अरे delta V 0 होता है तो work done, which has a general formula of P delta V, how much it is going to be? 0. Right? Yes or no? Yes. Now if the work done is 0, obviously there will be a change in first law of thermodynamics. Delta Q is delta U plus work done. Work done 0 for isochoric. So here we have delta Q is equal to delta U, and there it is. Got it? New to your channel? Array, welcome to the class. Okay, good. Kunal, it's very good to know that you know Japanese, but I have to let you know that, okay, on behalf of all my students, I don't think any one of us knows Japanese. So there is no point of you typing something there in Japanese, we will not get it. Okay, instead of Japanese word, even if you type dot, it will be having the same meaning to us, because dot and those Chinese and Japanese letters will not bring any idea. Yeah. Okay, fine. Good. Now देख ले, अभी देख ले. बाकी क्या है? अरे we need to draw the graph है ना, PV graph. बता दे कैसे होता है? अरे PV graph कैसे? Volume has to remain as a constant, so graph ऐसे होता है. It will be a straight line parallel to the pressure axis. ऐसे. No one knows Japanese. वो तो गलत बात है मेरा. Japanese people knows Japanese. You guys know. You guys love PJs, है ना? So here I am cracking all the PJs. So got it, right? देख ले. Any point you take on the graph, it will all be corresponding to the same volume. So it's an isochoric process. And last one, cyclic. Cycle वाला ding 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 ding. Sir, cyclic process क्या होता है? Ding 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 ding. Is that so? No. Right? Cyclic process means you start from a point. Okay, you go to another point, you go to another point, you go to another point, and finally, if you come back to the same point, right? We call it as a cyclic process. A thermodynamic process, a thermodynamic dynamic process which starts and ends at the same point, right? We call it as a cyclic process. ठीक है? Awesome. Okay. देख ले. Everybody listen here. And it starts from the same point, ends at the same point. अरे starting point भी ending point भी same है, तो what will be the change in temperature? Zero होता है, because it starts from the same point temperature. It will be a constant value of temperature. It will be ending at the same temperature. So change in temperature zero होता है. अरे change in temperature zero होता है, तो delta U का वैल्यू क्या होता है मेरे बच्चे लोग? होता ही है, ये zero होता है, वो भी zero हो जाएगा. Got it? Right? Okay, fine. So all the first law of thermodynamics, all the thermodynamic process is over, and almost at the last part, which is the second law of thermodynamics, right? Okay. First law of thermodynamics actually talks about the energy conversions, right? What is happening to the heat energy? How much of heat energy is getting converted to internal and how much is getting converted to work done, right? The conversions about the energy is actually being told in the first law of thermodynamics. Then why should we have the second law of thermodynamics? It's very simple, right? Listen to me here, dekh le. First law of thermodynamics cannot say whether a process can happen or not, right? So if you want to give some boundaries, okay, if you want to give some conditions to know whether a thermodynamic process happens or not, that is given by second law of thermodynamics. Actually, second law of thermodynamics gives conditions, okay, to know us, or to help us know that whether a thermodynamic process happens or not. Fine, I'll explain you. Thermodynamic process is being explained in two different statements. One is Kelvin Planck statements. Okay, what is actually the Kelvin Planck statement? Everybody listen here. Okay. Kelvin Planck statement tells that, right, it is possible for the work done to get converted to heat energy. Okay, and it says the entire amount of heat energy cannot be converted into work done. This is what is said in second law of thermodynamics. What does it mean? A simple example I can give you. Dekh le. I'm rubbing my hands. And kya kar raha hai main? I'm doing a work, right? Okay. When work is being done, isn't there a heat energy production between the palms? Yes. So we can simply say that when I'm doing work, heat energy can be produced here. But it is not necessary that all the time heat energy has to be converted into work, right? This doesn't has to happen all the time. So let's put a cross mark here. It will not happen all the time, which means, let's say both these palms, I am inserting this into a hot water. Matlab heat energy is being provided to my palms, but is it making my hands to rub here? Matlab is by providing heat energy through that boiling water to my hands. Okay, heat energy is being provided. Is it making my hands to rub each other? No. Matlab work is not being done there. Matlab it is not necessary that always heat energy has to be converted to work done here. Okay, this is the second law of thermodynamics according to Kelvin Planck statement. Now there is one more statement for second law, which is a Clausius statement. And what does it say? It's very simple. Okay, the Clausius statement. Let's see what it has to say. Clausius statement says that the heat energy will only be transferred from a hot body, okay, to a cool body. The heat energy is being transferred from a hot body to a cold body. It happens by itself. Matlab, we know those processes which happens by itself without any external support, right? We call it as spontaneous process. You guys have learned it, you know, in chemistry. Spontaneous process it is. It also says one more thing, right? The heat energy delta Q cannot be transferred, cannot be with a cross sign from a cold to hot body. Will there be? Let's say I am taking ice and water. Obviously, the heat energy will be transferred from water to ice, right? Heat energy spontaneously cannot be transferred from the cold body towards a hot body. This is the basic law, right? And this is explained in the Clausius statement. Okay, these are the two different statements given for second law of thermodynamics, and these are the two laws, let's say, right, which can actually provide some conditions, right, for any thermodynamic process to happen. This will let us know which all thermodynamic process will happen and which all will not. Okay, and the last concept, which is reversible process, and after this done. 5 more minutes, Mansi. Ho gaya hamara. Okay, reversible process. What is a reversible process? A process which can go from one point to a final point, from an initial to final, and if it can return back from the final state to the initial state along the same path, then we call it as a reversible process. Dekhiye, you can understand it better from a pressure volume graph. Dekh le, initially the entire system was at the point A or the point 1. It moves to another point 2 through this path. A process, a thermodynamic process, is called reversible if and only if the system can move from the second state to the first along the same path as it. Okay, then we can call it as a reversible process. Matlab, this is the case. Is it clear? Okay, so this is called as a reversible, and if it doesn't happen, obviously it is irreversible, right? Okay, and there we come and end to this particular chapter, and I hope you understood just now that there is nothing much more to learn from this chapter. And a new chapter hai. Got it? Sir, who found all this? अरे बहुत सारा साइंटिस्ट है, बहुत सारा साइंटिस्ट है. Clear? ठीक है, तो हम खत्म. And that was the last part of today's class. And I hope you all understood. Best teacher, thank you. I hope you all got it, right? Okay. Now, bacha log, let me tell you, if you want to grab some scholarship for your college, at least let's say for a scholarship of 20 lakhs, Unacademy Prodigy scholarship test is your best chance. Next exam is going to happen on Feb 6 from 12 to 1 p.m. and you all can enroll. It's completely for free. Just you need to use the code of AMB10. Fine. Okay. And if you get first rank, second rank, third, fourth, fifth, what are amazing gifts you're going to win is simply, you can see it there. Those amazing gifts are waiting for you. Now, special class timetable, I'll soon update you. So thank you so much everyone. Numericals, this is a simple class for completing the theory. Fine. So I hope you all have enjoyed this class. है ना, नन्नू मुन्नू concept था, छोटू मोटू chapter था. Okay. There is some issues here. If possible, I'll do it in a PDF. Okay. So thank you so much everyone. It was the best class. Thank you, Abhimanyu. Thank you. Okay, see you all in the next class. Those who haven't liked the session and shown some love towards your bhaiya, this is your chance. You all can do it. Right, 12th standard students, we all can meet at 8 p.m. today with a new chapter of atoms at 8 p.m. Till then, bye bye and take care.